Okay, the Masked Professor is once again on the air, or can be streamed by YouTube. You'll notice new fashionable face mask. Luckily, I'm here by myself. I can take it off. I tell you, wearing a mask for long periods of time is uncomfortable. All right, so I am going to go through some case studies of applied ethics. These are from the Markula Center for Applied Ethics at Santa Clara University. All right, and they give me ethics cases sorted into the following categories. Let's start with academic ethics. All right, so here is a solar falsifier, and this is written by Jocelyn Tan. Jeremy is a fellow for his university's Global Service Fellowship Program. In this role, he must work with an international nonprofit organization, Solar Solver, to develop a portable solar system, solar panel kit for rural villages in Belize. During a visit to the company's headquarters, one of the organization's representatives, Shirani, asked Jeremy about using the fellowship's grant money to purchase items not readily available in Belize for Solar Solver. Since fellowship funds were obtained through a reimbursement process, she wanted Jeremy to falsify receipts from solar kit related purposes to obtain the money. Jeremy's first instinct was that it would be unethical to use money intended for one purpose to fulfill another. However, he recalled Shireen doing him several favors in the past. For instance, prior to his admittance into the fellowship, Jeremy had worked closely with Shireen and other Solar Solver representatives to develop a proposal for his project. If it were not for her help, as well as her company's help in sponsoring the project, Jeremy strongly believed that he would not have received the fellowship. Another time, a power outage occurred while he was demonstrating the solar kit's operation and an installation to local villagers. Jeremy tried calling Solar Solver's headquarters, but it was already past sundown and nobody was in the office. Finally, he decided to call Shireen's house for help. To his relief, Shireen answered and immediately sent a team with portable light generators to Jeremy's rescue. Jeremy is grateful for Shireen's for Shireen's act of kindness, but he does not believe that falsifying receipts is the right thing to do. What should Jeremy do? Jeremy should absolutely not falsify receipts. This falls under avoiding deceptive acts, giving testimony in a straightforward manner. It is absolutely not a an action that would be good. Okay, well, this goes back to something that I have seen before, where a professor stole a student's work and published it as his own. Again, by Jocelyn Tan, it's called Inhibited Reaction. Dr. Nazir is a chemical engineering professor at the University of Eastlands. Traditionally, various professors from diverse institutions would visit Eastlands to learn about research conducted by the university's scholars, as well as explore potential collaboration. Last month, Dr. Nazir discovered that his department would be hosting a famous chemical engineering professor, Dr. Alston. During his 3-month visit, Dr. Alston observed various group meetings presented by Dr. Nazir and his students. More importantly, he learned a great deal about the research that Dr. Nazir was doing in the field of reactor design. At the conclusion of his stay, Dr. Alston returned to his institution without mentioning any plans for collaboration. A few months later, Dr. Nazir was ready to publish a paper he had written on his topic of research. However, through an online resource, he discovered Dr. Alston had published a recent paper that used identical theorems, background information, and results that Dr. Nazir had written in his work. The paper did not make any acknowledgments to Dr. Nazir. The Eastlands professor was angry and felt betrayed. During his visit, Dr. Alston did not mention that he was conducting research or about to publish on the same topic in reactor design. Dr. Nazir's colleagues expressed disappointment in Dr. Alston's actions and in the field of higher academia in general. They urged Dr. Nazir to take action, but since it was not common practice, there had not been a non-disclosure agreement between the two parties in conflict. What, if anything, should Dr. Nazir do? Okay, this is actually a fairly common situation in academia. As I mentioned, a friend of mine who was a student had a professor steal his entire paper and publish it as his own. And I have heard of other instances where I did not know the principles myself. Principles, principals, not principles. Dr. Nazir absolutely has a right to call up the journal or write them and inform them that the research was stolen from him. This might end up being a huge fight back and forth where Dr. Alston might claim that he had done this research himself. Very often in cases like this, what ends up happening is what my friend did, which was just more or less to note that the professor had stolen his work. He informed myself and our bosses, one of whom was well, actually both of them were professors, one at St. Mary's University in San Antonio, Texas, and one at Texas A&M. Unfortunately, the last I heard of this professor, he was teaching still at a university up north. All right, let's go to engineering business and see. Let's choose to ship or not to ship. That is the question. This is by Claire Bartlett. To ship or not to ship. Rachel works as a quality assurance engineer at a large electronics company. She is responsible for the final testing of her company's servers and is part of a team which decides when new products will be shipped to distributors for sale. Rachel's company had a contract with another company which makes the chips which are incorporated into servers Rachel's company makes. The business model for this product is to release a new generation server approximately every 6 months, meaning Rachel has a limited time frame to conduct her quality control tests. Because there is such a short amount of time between the release of each next new product, the quality and assurance department cannot perform every possible test on the servers to ensure they are defect-free. Rachel will not ship a product if there is any possibility that the server could malfunction and cause physical harm to the customer. However, she will ship a product that has a higher likelihood of failure, resulting in data loss for the customer, because she knows that if she doesn't, her company's competitor will. Is this an ethical way to conduct business? How should she determine when to ship a product with known defects? Okay, so Claire gives us a pretty interesting question. I know that very often companies ship defective products. I always assume they ship them unwittingly, that tests have not been performed on each individual product. However, it is a breach of the honesty expected of an engineer to ship products you know very well might be defective. What should she do to rectify this? One thing to do would be to ask the company to increase the size of her department so that they can run more tests, possibly on every server, although that may be very difficult, or to improve the efficiency of testing all the way around. Here is what appears to be an excellent time case study. Time Sharing Space, once again by Jocelyn Tan. Ramona is an intern at an up-and-coming power electronics startup. On her first day of work, she was shown around a laboratory where she would complete most of her projects. During this time, she was also introduced to 9 male interns who would be sharing the same lab space. Since the lab could only accommodate 5 interns at a time, a vote was held to determine who would work in the lab during the day. In other words, for example, 8 a.m. to 4 p.m., and who would work at night. For example, 4 p.m. to 12 a.m. during certain days of the week. The morning shift was a popular option for a majority of the interns. Ramona was fortunate to be selected for 4 out of 5 morning shifts. Weeks passed. Ramona had been enjoying her work and almost completed one of her projects. However, one day a fellow intern asked how she was doing. Ramona commented that she was good but tired. The intern replied that Ramona had no reason to be tired because she was working mostly day shifts. Ramona was offended but chose to ignore his comment. The next day, she ran into several interns, one of whom was the one she encountered the previous day. At some point in the group's conversation, the same intern made a remark about how Ramona always got her way in the workplace because she was a girl. Ramona was upset. However, she did not want to cause a scene, chose again to ignore his remark. During the following weeks, Ramona tried to avoid the intern who made the inappropriate comments. However, certain settings forced her to interact with him, and in those times, he made a point to make Ramona feel guilty and trivial. Because she did not observe him behave condescendingly towards the other interns, Ramona speculated that her colleague held a prejudice towards female engineers. How should Ramona respond? Discrimination in the workplace based on any of the protected classes, whether that means a gender discrimination, a racial discrimination, discrimination based on creed, in other words, religion or ethnic grouping, or somebody who's handicapped, etc. That's just wrong. Now, in this case, there's nothing blatantly discriminatory. I would say that Ramona should respond in this case by keeping a journal of these remarks in case they begin to escalate and become a problem that she can show her superiors if need be. But if it's just a few remarks here and there that aren't necessarily discriminatory, I would say act like you don't even notice. Man, these engineering business case studies I'm really liking. Apathy Over Anonymity. Nabila Dean. Satomi works in a research facility that provides statistical results for the bioengineering firm TechCure Case. She is one of 4 interns expected to go through hundreds of samples per day. At her first week on the job, her supervisor informs her that all blood samples are to be completely anonymous. No testing can be done if personal information is revealed, meaning the samples must be properly disposed of if opened, or returned to the physicians if unopened to be re-anonymized. For the first 5 weeks, most of the new interns follow procedures to check that samples were anonymized before testing occurred. However, one of the interns, Max, failed to verify whether the samples were anonymized. Halfway through the testing, Satomi discovers the non-anonymized samples. She considers whether they should tell their supervisor, but the other interns ask her not to speak up so that they won't get in trouble. One of the interns argues that as long as they remove the information from the non-anonymized samples, the batch would otherwise be fine. Max is hesitant to go to their supervisor as it is his fault, but Satomi can see that neither does he like the idea the other interns are suggesting. What should Satomi do? I would say what Satomi should do is go to the supervisor and say that by accident some blood samples were being tested that had not been anonymized. Look, we all make mistakes in life. A lot of people try and cover up their mistakes and pretend that nothing happened. But that's not the right way. Always we want to go ahead and admit our mistakes, take the lesson from having made that mistake, and move on with your life. I remember something one of my teachers once told me. A liar must have a good memory. Okay, another excellent one. Let's return to looking at engineering business after a while and look here for a moment at science and research ethics. Oh man, I'm having a lot of trouble talking today. Okay, well, I noticed that the first 3 cases are ones that we already looked at. Okay, Questioning a Mentor by Claire Bartlett. Colleen was very excited to be accepted into graduate school and will be conducting her scientific research under one of the field's up-and-coming names. Her research advisor, an assistant professor, is doing well and is coming up for tenure the next year. Right before Colleen starts working in his lab, he had published multiple papers which were considered to be a breakthrough in the field. Colleen sees there is opportunity for further investigation on the topic and wants to base her research on these findings. However, when Colleen begins working in her advisor's lab, he directs her and the other grad students away from his recent findings and assigns their research in a different direction. Colleen finds this strange, especially since further research could lead to even more publications for her advisor. Her advisor continues to direct people away from this project until he receives tenure. After receiving tenure, her advisor finally goes back to the project and repeats the experiments. Although some of his results are similar to his original data, altogether they no longer support the scientific breakthrough of his original findings. This leads Colleen's advisor to retract some of his publications, work that Colleen knows earned him his tenured position. Since her advisor did not allow others to work on this project and only repeated the experiment after receiving his tenured position, Colleen suspects that her advisor knew something was wrong with the data and did not want to risk his tenure by trying to repeat the experiment too soon. However, she has no concrete evidence that her advisor did anything wrong. What should Colleen do? I would say in this case she should do nothing. She has no firm evidence. The research that her professor had done in the first place may have had some kind of inherent bias that he did not detect at the time. And if that is the case, he was perfectly right to withdraw the publications. So without any firm evidence that he knew his research had been in error, I would say it's better to just let that sleeping dog lie. All right, this is an excellent one. This is called This Land Is Your Land. Once again, by the famous Jocelyn Tan. Kara has been working as an environmental engineer at a consulting firm for over 20 years. Over 25 years, excuse me. Well known for settling disputes between her corporate clients before litigation must be pursued, Kara often analyzes technical data, particularly distributions of solid particle pollution, presented by disputing parties to help them reach a compromise on the cost of environmental cleanup. For example, two parties may be separated from one another by a strip of land. However, each party must fiscally contribute to keeping that land free from pollutants. In other words, they both have to pay. One day, Kara was contacted by a journalist to talk about her experiences at the firm. Kara spoke about how she often encountered cases where companies did not accurately depict levels of solid particle pollution occupying the company's respective surroundings. Instead, technical experts, who are mostly engineers, would misrepresent data in order to make it seem that minority parties were responsible for a greater part of the contamination. At the end of the interview, Kara emphasized the necessity of engineers taking ownership and being honest about the presentation of data. At what point does an engineer's interpretation of data move from sound technical reasoning to misrepresentation? How should engineers deal with the pressure to come up with data that may indicate favorable results for their employers? Okay, well, first of all, it's bad science to misrepresent data. That does not rise to the level of probity expected of an engineer or a scientist. I'm not saying it's never done, because certainly it is at times, but it is not right, and that falls outside ethical bounds. Let's see if we can make this a bit larger, since I know you guys are not able to read at the size that we originally started at. Apathy, questioning mentor. All right, trimming data by our old friend Nabila Dean. Joaquin was hired as a senior researcher for a medical research facility. His department has been developing a new medical device to detect HIV faster and cheaper. And the facility has promised investors a prototype would be ready in a year. However, the preliminary results have been somewhat disappointing, as only 60% of the case samples have tested positive for HIV, whereas the expected sensitivity was aimed at 80%. Product development had been extended for another 6 months, but additional funding is needed to continue the project. Concerned about the low true positives detected in HIV cases, senior managers decide to convene with their scientific advisors, who are under non-disclosure agreement, to determine if 60% is sufficient, if the study is adequately powered, and if there is a better way to evaluate the data. Before the meeting, Joaquin's boss asked him to trim the data by reporting results only from certain samples and filter out samples with low yields through observations made during meta-analysis of the clinical data. Joaquin is uncomfortable with trimming and argues with his boss that the Scientific Advisory Board, or SAB, should see all of their analyses unfiltered and filtered because it's valuable information that could be telling them something about disease stage or test performance. His boss states that as long as they don't lie about the numbers, there's no harm in filtering. Joaquin counters that they should show a flow chart of the numbers they started with, clinical metadata groupings, analysis methods, and filtering steps so that all the information is laid out openly. In this way, the Scientific Advisory Board has the opportunity to ask about the methods used to achieve their receiver operating curves and better understand the clinical cohort subclassification applied to the analysis. The more they argue over the discussion, the more his boss is unwilling to relent. Joaquin knows that the scientific advisors will expect to see sensitivity and specificity data, ROC curves, ROC, I believe they mentioned earlier, I am going to say those are relative correlation curves, false positives and false negatives, and figures of all unfiltered data. While the device is on its way of determining positive HIV results, it is not there yet, so he understands his boss's reluctance to share the information. How should Joaquin and his boss address this problem? Okay. Sometimes when we collect data, we throw out certain samples as being unrepresentative samples. That can come from, first of all, if the test was performed while the testing machine was warming up by an unreliable operator, or another way that you feel like the data is suspect. However, all data should be reported at least in the appendix, and you should put in a note about why certain data was thrown out. In this case, I would say that they should, if they decide there's some good reason that some data should be filtered out, they should take that out. They should report those, all the data results, but they should also report why this certain data was removed. Okay, well, you know what? Let us move to another category, civil engineering. We do not have a civil engineering program here yet. we are hoping in the future that will be added. That is on our wish list, our strategic plan for engineering. All right, so let's go with a marshlands fleeting flourishing. Once again by our old friend Jocelyn Tan. Solomon is a principal engineer at an environmental engineering consulting firm. His main role is to advise clients on what type of action to take when they are faced with risks and liabilities while conducting certain projects. In one case, Solomon had a client that wanted to expand their campus until it was within approximately 50 meters of a marshland. After construction of this extension, however, the client must ensure that a proper waste management plan is in place so that contamination will have minimal effect on the surrounding habitat. The client came up with a solution that satisfied but did not go beyond the bare minimum of state regulations. In other words, although Solomon's client prioritized a cost-effective plan, the environment would be subject to a certain percentage of contamination that would, within 5 to 10 years, stifle the marshlands flourishing. Should Solomon push for a more fiscally demanding yet sustainable strategy at the risk of his client backing out of the partnership altogether? This is an excellent question. As I have mentioned in the discussion on green energy and our several mentions of sustainability in this class, we are trying to set a higher example and leave things as clean or cleaner as we found them. Unfortunately, this is not always possible. I would say that Solomon should push for a more fiscally demanding and sustainable strategy. I would say, though, that he should organize his arguments very well. It's not going to be easy to talk a company into spending more money than the absolute minimum, unless you have some kind of situation where you have somebody who is really interested in protecting the environment. So I would say he should push for a more sustainable strategy, but if they will not go for that, he will have to ask himself whether or not he wants to continue with the project. Here is a possible problem that you may run into in your life as an engineer. Giving In or Giving Up by Claire Bartlett, the inventor of the Bartlett's pear. No, wait, I'm lying. She didn't do that. After earning a graduate degree in engineering management, Ashton began working for PDRC International. This is a company based in the U.S. which offers engineering, design, and construction services to countries all over the world. Ashton's work is focused on international development. Her first assignment is to lead a team to develop a bid for a highway construction project in East Africa. After the engineering proposal is submitted, Ashton is proud of the work her team has accomplished and promises her manager she will do everything possible to make sure that PDRC receives the contract. PDRC's bid is well received, and Ashton and her team are flown to East Africa to finish negotiations. Ashton is thrilled when her company receives the bid. The only stipulation is that they build their construction headquarters in a specific region in the country. Ashton then begins scouting the region for a location to build their headquarters. In order to obtain building permits in the region, Ashton has to negotiate with the local government. As she begins negotiations, she realizes that bribery is both a common and expected practice. If she does not bribe the local officials, she will not be able to build PDRC's headquarters in that region and consequently will lose the contract. Her first managerial project will be a failure. However, it is illegal for a U.S. citizen to bribe a foreign official in order to obtain business. If she is caught for bribery, she could face jail time, and her company could be fined millions of dollars. What should she do? Okay, well, as you saw in the National Society of Professional Engineers Code of Conduct, engineers should not engage in illegal conduct or allow support illegal conduct. I would say that she needs to call her company's headquarters, tell them the situation, and say, we can't do business here. However, if you find yourself in the same situation, you need to realize some companies are going to go ahead and engage in the illegal conduct. If that is the case, you need to resign and get another job. All right, let's go to something we do have, electrical engineering cases. All right, here is a good one. Copyright concerns. What the hell? Again by Claire Bartlett. SDX Alliance is a large company that sells computers, computer components, and software. Ralph is hired as an entry-level software engineer at SDX Alliance. His first project was to assist in writing the code for SDX Alliance's new hard disk controller. He had previously worked on a similar system interning at a startup and had written a code which greatly enhances the performance of their product. Ralph quietly reuses this same code in the SDX Alliance product and does not think to tell anyone that he has used the code from his last job. His manager is thrilled with the speed improvements this code brings to the product. Before the product is released, it has to undergo a 4-month-long quality assurance process review. During the review of the product, it was found the code which Ralph developed had been copyrighted by the startup he had previously worked for. Even though Ralph had developed the code, his previous company still owned the intellectual property rights to it. When his manager informed Ralph of the problem, Ralph admits he did not realize he had made a mistake because he was not familiar with copyright laws. Ralph then goes on to explain that the startup he used to work for is now out of business and is unsure if SDX Alliance would be able to get in contact with the owner of the copyright. If SDX Alliance can't use Ralph's code, then it will have to rewrite the entire code of the product, delaying its release by many months. What should they do? Okay, well, there are several lines of attack here. One is to look to find the owners of the copyright of the code and buy that copyright from them. Many things are copyrighted and patented on the casually and then never really used. Now, it says in our setup here, oh, okay. So Ralph did use most of the code. So yes, if they cannot get a hold of the people with the copyright on the software, they are going to have to start over and write new code. Ralph should have known better than to use the same code. Having written code that would speed up whatever this software process is, that means that he already has gained the knowledge of how to write a similar code and be able to write a similar code again. I'm shocked, I tell you. Okay, it's not going to show us the headline for this one. Disclosure Dilemma. Once again by Jocelyn Tan. Dylan is a manager at a leading consumer electronics company. In his role, he must frequently interact with industry partners and customers. One day, Dylan met with a customer of one of his company's custom products. The custom product was a special chip for an electronic appliance that was currently in its final stages of review before market release. During the meeting, the customer wanted to know the method of making the chip, a process which was not specified in the given data sheet. The client claimed this information was needed to ensure that the chip would function properly when it was integrated with electronic appliances. At first, Dylan was uncertain. He wanted to give his customer more details if it was for the benefit of his client's final product, but at the same time was concerned because the requested information was protected under his company's non-disclosure agreement. Dylan decided to discuss the matter with his supervisor. However, Dylan's manager was overseeing many projects, and knowing that Dylan was capable and experienced, entrusted him to take care of the situation. When he returned to work the next day, Dylan received an email from his customer. The message stated that if the chip's manufacturing methodology was not disclosed, the customer would cease further investments in the product. Shocked, Dylan believed that if the customer would not abide by the NDA, he should tell the contract should be broken off. However, doing so would mean losing a significant amount of profit they had intended on garnering from selling the chip. On the other hand, sharing confidential information with his customer would cause negative repercussions, especially if his company were to discover the legal breach. Although it is highly unlikely that the extra chip information would be used by Dylan's client for malicious purposes, its disclosure would potentially affect his company's reputation, lead to mistrust in the company, and compromise Dylan's position. What should Dylan do? That old dilemma. Many times, companies will get a copyright or a patent on a certain type of a process. However, it is also legal to never get a patent on a business process or a formula that is being used. For example, Coca-Cola's formula is secret, is known only by a very few people, and has been a secret since the end of the 19th century. A few years ago, somebody was able to steal that formula and offered to give it to Pepsi for cash, one assumes. To their credit, Pepsi not only turned them down, but turned them in to the police for doing that. It's perfectly legal to keep a business process secret. But we have to remember, a secret is something that very few people know. My father used to say, a secret is something one person knows. we must not wildly disclose information. Now that could even be information given casually. For example, say you are working at a certain company, and you know people who also work in the same business at other companies, and occasionally you get together to have a few drinks and a few laughs together. You need to be very careful not to reveal anything about what your company is doing that could even potentially be secret. Right? So the process of knowing when people are fishing for information and not revealing that is called counterintelligence. And actually, when we worked at the Army Depot, they gave us some training on counterintelligence. And strangely enough, one time I was together with a bunch of my colleagues. We all worked for Texas A&M, but we were on contract to the Army Depot. We were at a restaurant in Corpus Christi, and we were, kind of talking, laughing it up, all that kind of stuff. And a guy came over and he started talking to us, and we're talking to him. But then he started asking questions that were kind of pointedly at information that wasn't necessarily secret information, but it was information that was in a category called for official use only. Some of the guys started to talk about that, and I reminded them that we could not talk about that. And as soon as I reminded them of that, that guy made his excuses and left. Okay, a couple more case studies, and then I promise I'll stop. Let's go to my first love, mechanical engineering. Boy, I like that. I need to here's an excellent example. Off the Clock by our old friend Claire Bartlett. Sarah, let me see if I can make this even a little bit larger. Wow. All right. Sarah was recently promoted to a managerial position at her industrial engineering company. With her new position, she is now responsible for overseeing the company's production factory, meaning approximately 50 factory workers now report to her. Although Sarah previously worked as an engineer and does not have any experience running a factory, she is excited to begin her new position. At the end of her first day, Sarah is confused to see her factory workers continuing to work well past the end of their 8-hour shift. She then goes to the factory supervisor, who reports to her, to express concern because the factory does not have the budget to pay so many workers overtime. The supervisor smiles at Sarah and explains that the factory meets production goals by making the factory workers work off the clock. The workers are well aware of this expectation and went along with it in order to keep their jobs. Sarah is shocked to learn this illegal practice had become part of the company culture, but the supervisor explains that the company's CEO, who is Sarah's boss, is well aware of this expectation. What should Sarah do? Sarah needs to go to her boss, the CEO, and say, this is not right. That we need to take steps to either be able to complete the workload within an 8-hour day or pay these workers overtime. There are many precedents here in America for companies getting soaked for big fines in this area. For example, there's a huge retail company, which I will call Mallwart, that has been sued many times for making people work unpaid overtime or erasing their hours if they work too much time. Now, when Sarah goes to her boss, hopefully he will see the light and know what needs to be done is to either improve efficiency or be willing to pay for the overtime. If he doesn't see the light, I would suggest Sarah look for a new job. And depending on how gross a violation this is, possibly report this to the Department of Labor. Okay, well, apparently I have to go back down to well, I promised to return to engineering business. All right. Misinterpretation Mishap by Jocelyn Tan. Tony is a project leader at a company frequently subcontracted to produce code for various U.S. government entities and affiliates. Traditionally, code that was developed for one federal department could be reused for another if approval was obtained by the former. One day, Tony's company was contracted by a privately owned commercial corporation, FlyHigh, to create code for an avionics-related image processing effort. Since the code requested was almost identical to one used for a past project, Tony's team decided to, once approval had been obtained from the government, reuse the code. After permission was granted through email, however, Tony realized the approving party, a law agency that was contracted by the government, lacked complete understanding of who would benefit from the reused code. Tony wanted to contract the government directly to ensure that it had been informed of all vital aspects of the contract, but realized doing so could mean having the initial approval revoked, having to recode the requested code, and increasing the contract bid up to $2 million. Understanding the contract between his company and FlyHigh was on the line, should Tony move forward with clarifying the situation to the appropriate party. Theoretically, Tony is in the clear. He doesn't know that this law firm doesn't understand all the nuances of the code. However, I think that Tony should proceed with trying to get the governmental entity that originally contracted for the code to approve this directly rather than have the law firm do so. If that proves impossible, either to get approval or to even speak to the entity, I would start writing new code. All right. Let's look at bioengineering. That should be nice and juicy. Trimming data. Here's a good one. A Lengthy Dilemma by Nabila Dean. All right, let me ratchet up the size again. Monica has been working at a large medical company that reviews lab procedures on blood samples shipped in weekly. On the first week on the job, her supervisor went over the procedure the company uses that gives the institution permission to use blood samples for laboratory testing. One part of the procedure is to collect signed informed consent forms for each sample. Monica knows that if a sample does not come with an informed consent sheet, the sample must be returned back to the supplier. Almost a year after she started, Monica comes across an unsigned consent form, 14 pages long, with incredibly small font. Her initial reaction was to return it to the supplier to obtain the necessary signatures. However, reading through the first few sentences of the form, she wonders if the consent sheet is sufficient to inform a patient about the possible risks the possible risks involved with consenting to their samples being used, even if it were signed. It takes her about an hour to read through the entire form, and at the end of it, she is certain no patient would take the same amount of time to read it. Furthermore, the text is complex to read due to all the technical vocabulary and could put the organization at risk if challenged. She wonders how the draft of the consent form with the company could have been reviewed and approved by the Institutional Review Board. Monica has serious questions about the ethical basis of using this form, how it was approved, and by whom. She wonders whether to bring it up to her boss in order to see if there's something she hasn't understood. Her co-workers shrug it off, saying they have seen numerous consent forms similar to the one she found, and some that were even longer. Should Monica return the form back for a signature from the supplier without comments, or should she speak with the boss, her boss, about the process used to accept the forms? Monica should absolutely speak to her boss and ask him. We must not leave ethical questions hanging out there without figuring out what is going on. Here at school, we have an IRB committee, which I sit on. That IRB committee has to approve any kind of human subject research. That includes something as simple as a survey. Anytime we're getting medical samples, the stakes go even higher. Usually a survey approval is almost a rubber stamp. We see the survey, they've got their forms lined up, we say, yes, you can do that. Medical research has to be at a much higher level of approval. It needs to be scrutinized that we are not putting the subjects in undue danger due to our research. She should definitely ask. She cannot process a sample where the consent form has not been signed at the very least. Oh, okay. Okay. Let me many colleges and universities have something like this, a Center for Ethics. Many engineering programs and science programs have a requirement to take an entire ethics class. Ethics are very important. We must always stay within the bounds of the law, of honesty, and doing the right thing for our employers our clients, and ourselves. Okay, well, thank you very much. I'm going to call it a day on this session. This is the session of 423 being recorded here on 424. Y'all have fun now. Stay safe, stay healthy, and when the fields are white with daisies, we'll meet again.